Hi all. Today we are going to learn about a dimensionality reduction algorithm, which is PCA, Principal Component Analysis. Dimensionality reduction is very important to lower the complexity of the program and to increase the speed of the code run. So PCA is one such algorithm which will reduce the dimensionality, that is the number of features in your data set, to make your work easier. So today we will see how PCA can be implemented. So we are going to use the iris flower data set, which has 4 features, and we are going to reduce it to 2 features. So we'll get started with the program. First, we need to import all the necessary libraries. For numerical calculation, we are going to use NumPy and Pandas. And next, we are going to load the iris dataset from sklearn. And also, we are going to load the algorithm for PCA from sklearn. And next, for the plotting purpose, we are going to use matplotlib pyplot. In the next step, we are going to load the iris dataset into the variable iris. And whatever the features, the data we have, we are going to store it into a variable called data. And the target variable which we have, that is the species of iris flower. That is, mainly we have 3 species, and that target value will be stored in a variable called labels. And next, here the label names will be stored in label underscore names. In labels, we have the actual data for labels. In label underscore names, we have the name of the species, that is the heading of the features or the columns. So now we have data, label, and label names. Next, for the purpose of better visualization and understanding, we are going to convert the iris dataset into a data frame using the pandas library. That is, the alias which we have used for pandas is PD. So using that, we are going to convert it into a data frame, and that will be stored in a variable called iris underscore df. Using the iris underscore df.head function, we can see the initial rows of the data frame, that is the data set. Next, we are going to use the PCA, that is we are going to fit this PCA model, and the number of features we require is 2. The initial features are 4, but we require 2, that is we are going to reduce the dimensionality to 2. That's the reason we are going to pass the argument as n components is equal to 2. That is the end result, the number of features, the end features we require is 2. That's the reason we are going to specify 2 for n components, and we are going to use PCA algorithm. Next, we are going to transform that data, and the data set which we initially had will be reduced to 2 features that will be stored in data underscore reduced variable. Next, for that, we need to create a data frame. In the next step, that is what we are doing. We are going to convert that data underscore reduced data into a data frame using only 2 features, which is principal component 1 and principal component 2. Earlier we had 4 features. Now we have only 2 features. The next step is to plot the graph. We have reduced the dimension from 4 features to 2 features. Now we need to use the pyplot library to plot the graph to see the result. So this is the next set of lines, tells us the way of creating a plot or a graph. Here we are using scatter plot, which will look something like this. This is the output. Here we have only two features, principal component 1 and principal component 2. Initially we had four features. Now as a result of dimensionality reduction algorithm PCA, we have only two final features, and these are the data points which belongs to either one of the target values. That is the species of iris flower. Thank you.